Welcome to Future Forward, everyone. Today, we are diving into a topic that I honestly believe will redefine healthcare as we know it, and it is coming a lot faster than most people think. We are talking about humanoid robots, AI-powered, stepping into the operating room. My prediction, within 3 to 5 years, we will see these machines not just assisting, but performing surgeries with a level of precision and consistency that human hands simply cannot match.
Mark, it is always good to be here, though I am afraid I have to pump the brakes, quite forcefully, on that particular vision. 3 to 5 years, flawless, free? With all due respect, that sounds less like a carefully considered prediction, and more like marketing copy for a Silicon Valley pitch deck. As a systems safety analyst, I look at the current state of AI, and frankly, what you are suggesting for surgery is not just optimistic, it is dangerously reckless.
Dangerous. David, this is about progress. Think about it. No human error, no fatigue, no tremors, no emotional bias. A robot can analyze millions of data points from previous surgeries, learn, adapt, and execute a procedure with sub-millimeter accuracy every single time. We are talking about eliminating human variability, which is, let us be honest, the biggest risk factor in many complex surgeries.
Eliminating human variability? Mark, are you serious? Let me counter with this. We still have AI and autonomous vehicles struggling with phantom braking on perfectly clear highways. We have systems that misidentify a plastic bag as a dangerous obstruction, or conversely, fail to recognize a child darting into traffic in an unusual light condition. If AI cannot reliably recognize a basic object or maintain consistent speed on a well-marked road, how can you possibly advocate for it cutting into a human body?
That is an apples and oranges comparison. David, autonomous driving is an open, unpredictable environment. Surgery is a highly controlled, sterile setting. We are not talking about robots navigating rush hour traffic. We are talking about a precise, pre-planned procedure within a defined, contained space. The input variables are significantly fewer and far more controlled.
Controlled, yes, but not simple. The human body is the most complex system known. It is not a static, mechanical assembly line. Every patient is unique. Variations in anatomy, tissue density, unexpected bleeding, unforeseen complications. These are not fewer input variables. These are an infinite number of edge cases that require intuition, real-time judgment, and adaptability that current AI simply does not possess. A robot can follow a program perfectly, but what happens when the unexpected occurs, which it inevitably does in surgery?
But that is where the AI truly shines. David, machine learning means these robots will be constantly improving. They will not just follow a program, they will learn from every single procedure performed globally. Imagine a system that has seen and analyzed millions of appendectomies, knee replacements, heart surgeries. It can detect subtle anomalies that a human surgeon, even an experienced one, might miss. That is a level of cumulative expertise no human can achieve.
That learning is based on data. Mark, who curates that data? How do we ensure it is unbiased, complete, and accurate? And more importantly, how do we validate the learning process to ensure it is not learning the wrong things or developing blind spots? We are talking about life-critical systems. The burden of proof for safety is astronomical. You do not just iterate and improve on human lives. There is no undo button in surgery. When an AI makes a mistake, it is not a software bug. It is potentially fatality.
You are painting a doomsday scenario. David, we are not talking about sending an AI into the OR unsupervised from day one. There will be human oversight, regulatory bodies, extensive testing, but the underlying technology is advancing exponentially. The precision of robotic arms, the sensory capabilities, the real-time processing power, these are no longer science fiction. They are here, and they are getting better every single day. The cost benefits alone are staggering. Imagine universal access to world-class surgery, regardless of geography or economic status, because the surgeon is a mass-produced, highly efficient machine.
Mark, cost reduction is a poor justification for introducing unproven risk into a system as delicate as healthcare, and human oversight is a common cop-out. In complex autonomous systems, the human operator often becomes a mere monitor, losing situational awareness and the ability to intervene effectively when things go wrong, especially if the AI's actions are opaque or too fast for human comprehension. We have seen this in aviation with highly automated cockpits. The human becomes a liability, not a safety net.
But is not the argument the same saying we should not have planes because they might crash, or cars because they have accidents? We accept calculated risks for progress. The number of medical errors, infections, and complications caused by human factors annually is staggering. An AI surgeon, properly developed and deployed, has the potential to drastically reduce those numbers, saving countless lives and improving outcomes dramatically. It is about a net positive.
It is not about rejecting progress, Mark. It is about responsible progress. My point is not that AI will never be in the OR. My point is that the leap from phantom braking to flawless surgery in 3-5 years is a chasm, not a step. We need to demonstrate mastery of foundational real-world tasks with incredibly high reliability before we even consider touching human lives. The safety case for autonomous surgery would be orders of magnitude more complex than for autonomous driving, and we are decades away from that, not 3-5 years.
But David, the advancements in specific domains are incredibly rapid. We are not talking about general AI yet. We are talking about narrow AI, highly specialized for surgical tasks. Think of the Da Vinci robotic system today. It is already extending the capabilities of human surgeons. The next step is handing over more and more of the autonomy, with built-in redundancies and safety checks. It is an evolutionary process, not a sudden revolution. And the market demand, the human need, is immense. This is not just about technology. It is about solving real-world healthcare crises.
The Da Vinci system is a teleoperated robot, Mark. It is an extension of the surgeon's hand, controlled directly by a human. It's fundamentally different from an autonomous system making its own decisions. The critical difference is authority to act. And while specialized AI can perform certain tasks very well, surgery requires a holistic understanding, a synthesis of visual, tactile, and contextual information that current AI models struggle with even in simulation, let alone in the unpredictable live environment of a human body.
But that is where the integration of advanced sensors, haptic feedback, and real-time imaging comes in. Imagine AI that can process an MRI, a CT scan, and live ultrasound data simultaneously, creating a dynamically updated 3D map of the patient's anatomy, guiding the robotic arm with unparalleled precision. It is about combining multiple technologies to create a superior outcome. We are talking about a level of awareness and control beyond human capability.
Every one of those integrated systems introduces new points of failure: sensor degradation, software glitches, communication lags, power failures, cybersecurity threats. When you layer complexity, you multiply the potential for catastrophic failure. And who is legally liable when an autonomous system makes a critical error during surgery? The manufacturer? The hospital? The overseeing human who could not possibly keep up with the machine's decision-making process? These are not trivial questions to be brushed aside by a 3-5 year timeline.
These are all valid concerns, David, and they absolutely need to be addressed. But let us not let perfect be the enemy of good, or even excellent. The potential for good here is too vast to ignore. We are talking about vastly increasing surgical success rates, dramatically reducing recovery times, and making high-quality surgical care accessible to billions. The ethical and regulatory frameworks will evolve alongside the technology, just as they always have. We cannot halt innovation out of fear.
It is not fear, Mark. It is prudence. It is understanding the difference between a controlled laboratory experiment and real-world deployment of a safety-critical system. We are talking about a field where acceptable error rates are practically zero. If an autonomous vehicle has a 0.001% chance of a fatal accident, it is still too high for mass deployment. For surgery, the tolerance is even lower. We need to see a proven track record, a level of demonstrable safety and reliability that is orders of magnitude beyond what current AI systems can deliver in any complex real-world task. And that simply will not happen in 3-5 years.
But is not that just a conservative mindset holding us back? The history of technology is full of skeptics who could not envision the next leap. People said we would never fly, never go to the moon, never cure diseases. The rate of technological acceleration is unprecedented. What seems impossible today can be routine tomorrow. I truly believe that the confluence of AI, robotics, and advanced materials will enable robot surgeons to outperform humans in a very short time frame. The benefits for humanity will be transformative.
And the history of technology is also littered with catastrophic failures born from overconfidence and underestimation of complexity. From the Thera 25 radiation therapy machine to the Boeing 737 MAX, the consequences of rushing unproven, safety-critical software into deployment are devastating. Surgery is not a game. It is not a move fast and break things scenario. It is a move cautiously and ensure nothing breaks scenario. My concern is not about the ultimate possibility, but the irresponsible timeline and the overhyping of current capabilities. We owe it to patients to be rigorously, unflinchingly safe.
I hear your concerns, David, and I agree that safety is paramount. But I also believe that humanity's ingenuity, especially when fueled by advanced AI, will find solutions to these challenges much quicker than historical precedents. The future of surgery is autonomous, precise, and accessible, and I am betting on it happening sooner rather than later.
And I'm, Mark, will continue to advocate for a future where innovation walks hand in hand with an absolute, unwavering commitment to safety. Until we conquer phantom braking consistently and reliably, let us keep the humanoid robots out of the operating room. Thank you for this lively discussion.
An important discussion indeed, David. Thank you for your critical perspective, and thanks to all our listeners for tuning in. We will see you next time on Future Forward, as we continue to explore the technologies shaping our world.